This is sometimes called the Fletcher's Trolley. I have two masses attached by a string. One mass is pulling downwards. I'll call that mass number 1. Gravity is pulling downwards on it. Of course, due to gravity. And of course, the tension, the string is pulling upwards, like so. I'll call it FT. Now, remember, force questions. Always start off by drawing a free body diagram, and in doing so, which forces are there, which is larger minus smaller. And I got a tug-of-war between these two. So in a tug-of-war situation, I find the best analysis that I like anyways is to think larger force minus the smaller force. Larger minus smaller equals the net force. And that's what I have there. Now, I've also got this other mass, of course. I'm just going to go over here. I'll call it mass number 2. Don't want to mix them up. It is being pulled on a surface by the string. So this tension force should be the same as that tension force, same string. Now, of course, gravity is pulling downwards, counteracted by the normal force going upwards. But those two will cancel each other out. So the leftover force here is the tension force. Therefore, the tension force is your net force. Therefore, it's M times A. Net force is always M times A. This is mass 2, so I better label that mass 2. Now over here, net force is always M times A, but this is mass number 1. Force due to gravity, M times G, and we do not have an equation for tension force. There's no equation we have for tension force specifically. Now I've got these two equations. Look at this and I see, well, I can't solve for that. I got two unknowns. I don't know the tension, don't know the acceleration. Likewise over here, I don't know the tension, I don't know the acceleration. So a little algebraic savoir-faire, you might say, when you got two unknowns, you better have two equations, and we do, and you can join those two equations together then. So let's take those two equations and join them together like this. Okay, tension force is M2A, this tension force. Then we start to rewrite this one here. M1A equals M1G minus, but instead of writing FT, I'll write what FT is equal to, which is M2A. That's shown by that equation. Ta-da! Now I only have one unknown. That's in two places, but only one unknown. So I need to do some algebra to combine those unknowns. I'm going to take this M2A, let's see, over to this side. All the A terms I'm going to take to the left-hand side. So I'll get M1A plus M2A equals M1G. It'll just stay there. Take out a common factor of A. M1 plus M2 equals M1G. And now I can isolate A, which is what I'm looking for, because that's going to be M1G over the sum of the M's. There, I'm going to have the acceleration. Fantastic. So how about let's work some numbers. A is equal to, okay, this is mass 1, and mass 1 is over here, and I'm told the hanging mass is 1.5 kilograms. I don't want to mix these two masses up. That's going to be so crucial. And mass 2 over here is 3 kilograms. So important not to mix these two masses up. So what do I have here then? For mass 1, I've got 1.5 kilograms times, I'll use an acceleration of gravity of 9.81. And now on the bottom here, M1 is 1.5 kilograms plus M2 of 3 kilograms. Pull out my calculator now. Of course, 1.5 times 9.81 equals, divided by 4.5 equals, and I have an acceleration of 3.27 meters per second squared. Great. There's the acceleration. Wonderful. How about if I also want the tension value? Well, I can take this acceleration, plug it in over here, and find the tension, but I think I'll plug it in over here. That's a little easier one to work with. So the tension, which is what I'm now looking for, is M2A, where M2, of course, is 3 kilograms. It's so important to write stuff down so you don't mix up things like those masses. Times 3.27 meters per second squared. The tension force is 3.27 meters per second squared times 3 kilograms. Oh, 9.81 newtons. That's something. So, at the end, our acceleration to 3 significant digits, we're told here, is going to be 3.27 meters per second squared, and our tension force in the string is 9.81 newtons, like so. And we're done.